Um, so thank you very much for joining us today, joining BlueCat for our webinar. It's our first webinar of the new year. Happy New Year to those of you that have joined. My name is Jim Williams, I'm Vice President of Marketing. We've got some audio coming back here, Maitri. I don't know if you can control that or not. My name is Jim Williams. I'm the Vice President of Marketing here at BlueCat, and today we're going to be talking about the recent Sunburst or Solorigate attack. Variety of names ascribed to this particular attack, and specifically we're going to talk about how it exploits DNS and what you can do about it. If you are managing critical infrastructure, DNS infrastructure, if you're on network ops teams, how you can work more productively with your counterparts in network security to help detect and mitigate attacks that look like Sunburst. I am going to be joined by a number of people here at BlueCat, including David Maxwell, who's our Director of Software Security, Andrew Wertkin, our Chief Strategy Officer, and Pablo Guerrero, who's the Senior Technical Product Manager. Okay. Before I jump into this, I expect that this webinar will probably take 30 to 35 minutes. We will stick around for as long as we have questions from the audience. And the best way to ask those questions is by using the Q&A feature, which is in the control panel of GoToWebinar. And we'll address those when we get to the Q&A at the end. We'll make sure we do that. We're also going to make a recording of today's webinar and the slides available to everyone who registered for this. We do that regularly with our webinars. So if you missed something, don't worry about it. We'll send it out to you, along with some additional material that you might find helpful. Today's agenda is pretty straightforward. We're going to do that overview of Sunburst Solorigate, exactly how it works, what happened, what went down. We're going to specifically dive into the role of DNS. We're going to talk about a number of steps, 3 steps here to protect enterprise DNS infrastructure from attacks that look like Sunburst or use techniques like Sunburst. We'll then have an open Q&A. And if you'd like to stick around for the bonus round, I like to call affectionately the backstage pass, we'll actually demonstrate BlueCat's DNS security products that help you to detect and mitigate attempts at DNS exploits like Sunburst. So stick around for that, and we'll take questions then too. Okay, so without further ado, let me go and hand it off to David Maxwell, who can take us through Sunburst. All right, David.
Thanks, Jim. So this is one of those attacks that made the news big time. It was probably the largest security incident, maybe ever, but definitely in the last 10 years. And it's one of those attacks of the category of supply chain threat, which means that you're receiving software from a third party that you depend on, and you put your hopes in them doing everything that they can to keep that software safe and reliable and doing what you need. But because they had a security incident, you've got the inherited risk that's come down to you running that software now. And as you'll see, there's quite a chain of events that fell out of that. So let's start to drill into the details. Who was potentially affected? Well, the vendor in question here is named Solarwind, and they have thousands and thousands of customers. They have a large suite of products, but there's one particular product in this case called Orion, which was the affected component. And you can see from the slide, there are some big names that have already published information about how they were impacted by this. There were actually up to 18,000 customers potentially affected that were users of the Orion software that had downloaded the version in question that had the Trojan malware inside it. And so we'll see the timeline a little bit more. You'll see exactly what happened. But this spreads across the whole range of Fortune 500 companies, banks, schools, hospitals, everybody from the top down of the internet was potentially affected by this. We were fortunate at BlueCat that we weren't users of the software in question, so we weren't directly impacted ourselves, but many of our customers were. So let's get into the details. So Orion as a platform integrates to many different parts of your IT organization. And that means that it has access to a lot of credentials, it has access to a lot of systems, and made it a very tempting target for a well-supported, capable attacker, threat actor to take advantage of. And so from the timeline, you'll hear that this went on for months, but in fact, there are a lot of indications that this effort was underway for over a year and a half before somebody actually noticed something. So there was a very complicated process they went through to compromise SolarWinds and then take advantage of that to compromise SolarWinds customers as well. So let's look at the actual timeline of events. So the first thing that happened was, and people often ask this question, were changes made to the SolarWinds source code? And the answer is not precisely, because the threat actor in this case was very careful. Once they got into the SolarWinds corporate IT environment, rather than injecting changes to the source code, which the developers may have noticed in the version control system, they instead made changes to the build system. That's the software pipeline that turns the source code into executables, signs those, and then prepares them to be shipped to customers. The fact that they were able to get into this portion of the process means that the changes were transparent to the developers. They didn't see any new code showing up in the code base, and the resulting executables that were generated were signed as per the normal process. So even if you as a customer were checking signatures of files and file hashes, making sure that everything was officially from SolarWinds, it was. You wouldn't have seen anything. And that makes this very difficult to predict and detect. And if you think about what we're recommended to do as software security practitioners, patch your system, stay up to date with security patches. That means that every day, every week, every month, you're trusting software from third parties. And that's the supply chain risk, is that you're dependent on these upstream vendors supplying good software to you. So in this particular case, the build was modified, a DLL file, a .NET DLL was added. And in fact, they seem to have done this in multiple stages. They added the new DLL, but without putting the malicious code in it months in advance, so that people who were watching, when the actual change happened, when the Trojan was added, they didn't see a jump in the size of the executables that were being downloaded because they'd already bumped up the space in advance. That seems to be one of the ways that they hid this from happening from even those who were being most observant and examining every download of a new version that came in. When that was deployed in a customer environment, it would wait for 2 weeks and make sure that it wasn't in a VM, wasn't in a analysis environment like a sandbox that looked for malware. And once it was certain that it hadn't been detected to this point, then it would start to reach out via DNS. And obviously, the BlueCat being DNS specialists, this is where the story gets especially interesting to us. And a lot of malware uses DNS because pretty much everything that happens on a network first does a DNS lookup of some sort before it starts making network connections, with very few exceptions. And this piece of malware was not an exception. And what it did specifically was it gathered some information about the local environment that the software had been installed in, a globally unique ID for the machine, part of the MAC address of the host that it was running on, the domain name internally on the network that it was running, and it hashed that up into a value that it used as a DNS query. And normally we think of DNS as being a database that serves mostly static responses, known answers in a sense that we've decided to publish. But in this case, the attackers had built a custom DNS server so that when those queries came in, it was capturing that information, using it to figure out who had been compromised, and then returning specific information to give the malware directions on what to do next. And in the general case, as I said, there were about 18,000 customers potentially that downloaded this Trojan version of the software. And as a result, you can imagine that the threat actors had their choice of where to spend their time. And with limited resources to investigate all of those customers, they picked the highest value targets according to their set of priorities. And since we don't know precisely who they were, we don't know precisely what their priorities were, but we do know the customers that in hindsight have detected these intrusions and are reporting on them now. And so the response to the DNS query would tell the malware what to do. And usually what it would do is tell it to download additional malware. And that additional malware then would start the internal infection inside the customer environment. So that takes a variety of different forms at different customers. And if we were really, fleshing this timeline out fully and not focusing on the DNS part, we would say here that different things happen, like the compromise of SAML keys, certificates that allow them to create new authenticators so that people could sign into, for example, Azure cloud environments using the corporate AD, and they could create backdoors that way. They also downloaded various types of malware to give themselves different ways to get back into the system. And that's one of the biggest problems with an attack like this is even if you detect the initial attack and clean up, you have to really go through all of your systems to know what else might have happened in the meantime. And as I said before, this went undetected for months. The software was shipped in the February timeframe of 2020, and it really wasn't until November, December that FireEye started saying, something strange is happening here, and then it took a few more weeks for the details to start to come out. And even today, we're seeing new statements publicly made by different companies, yesterday, today, on an ongoing basis, as further investigation reveals the depth of what happened. So let's go into the DNS part a little bit more. So that initial DNS lookup looks for a CNAME address at a specific domain. And so this is kind of similar to what you would call a domain generation algorithm, where the client is generating a string that it's going to pass through the DNS system, and it's encoding information in that query. And so, normal DNS, you look for www.google.com or something like that, but this is, looking for a string, and I'll show you some examples of those in a moment. The response to that DNS query then would be an address. That address actually provided information back to the Trojan to tell it what to do. And one of the things that they could do, for example, is give it back an IP address in a block list and say, shut down. We're not interested in this particular infection case. This customer is not interesting to us. And so we're going to just turn this one off. Note that when I get into the next slides and I start to show you the decoding of some of those CNAME strings, we don't know for certain that those infections were actually at those companies. In some cases, there are public announcements that they have found infections. But if you had an environment at home set up with example.com, it would show up as an example.com in the DNS. So people would see that in the logs. From that initial connection, you then got referred to one of a number of domains to make your control and command and control connection, your C2 connection. That gets sent over HTTP, and it was obfuscated. It was made to look like the Orion maintenance protocols, and but there was information hidden inside of hex strings in that HTTP. So there was a lot of dead content that was ignored, and then just some key binary that was pulled out and used to send commands to tell the malware to do specific things, like download a specific further piece of malware to start the lateral spread inside the organization. So on the next slide, we'll see examples of the specific strings. These are base64 encoded strings that go to this AV-SVM cloud, which sounds like an antivirus vendor. So if you were casually looking at this, you might think that that's a legitimate domain. And each of those researchers have published decoders for, and so there are thousands of examples of the names that were embedded in those strings. As you can see there, Cisco, NVIDIA, etc. And on to the next slide. And so here's an example of further decoding of some of that list. And so inside of BlueCat, our threat protection system added blocks for these domains when it became known that they were being used. But that's in the November timeframe, which is not as early as you might like to catch things. And so there are various other threat detection capabilities that we have that Andrew's going to talk about. And I think the next slide, we're going to hand off to Andrew.
Super. Thanks, David. Right. So let's talk about how BlueCat can help mitigate these risks. And obviously, it's really around DNS and understanding what's going on with DNS with different types of devices and applying appropriate policy. Can I advance the slide here, Jen? There you go. So where we've really pushed a lot from a security standpoint is with in our Edge product. And our Edge product really sort of sits as a resolver in the network, examining every single DNS query and providing all the visibility to those queries. So DNS is a rich signal, and Dave just showed you exactly how that signal was working within this specific breach. It's a very rich signal, and a lot of our customers want to make sure they have it, and they have not just the query itself, but the wholesome query and response, because also, as Dave said, some of this was information embedded in CNAMEs as well. So you want that entire CNAME chain. So grab all of that, make sure it's visible, and make sure our customers can action on it. We also do our own analysis in that system of those queries and allow creating policies. So beyond simply providing the signals, we can use DNS as a control point. If you know something's bad, DNS is an amazing, efficient control point. 80-byte query shutdown, and certainly isn't the only thing you would have. But again, if something is certainly known bad and the indicators of compromise are domains, and the majority of things are going to use the public DNS to go find something to go speak to its backend, DNS becomes amazingly efficient. So we can provide very simple policies there using our threat intelligence, and we use some from CrowdStrike and some other as well, or allow our customers to use their own threat protection. But importantly, there's more we can do. The world of that domain indicators and threat protection is really focused on what we know is bad already, and that leaves open this huge haystack to go find needles. And so we'll talk about how we can narrow that down through some of what we do and some of what which are the sorts of devices on your networks, what sort of devices are there, what they do, are they user-driven, are they not user-driven? All of this helps you sort of reduce the size of the haystack so you can find the needle. So Edge will find, will act as that resolver inside the enterprise, and then it will selectively forward in sort of very intelligent way to either internal IP space or internal name servers or public name servers as well, making sure that we capture a bit of everything. Jim, the next slide. So the real-time monitoring is key. This isn't just a passive system that collects the data. It's a system that, again, is collecting the data, but is also a control point because it's in the DNS query path. And because it's in the DNS query path, we can examine the queries and then, based on policy, determine what to do. Do we want to simply monitor these because they're domains that may not be bad, but domains that we don't necessarily know are good? That becomes very interesting when we talk about specific types of devices, and I'll show you an example of that in a second, where you can predict what DNS queries it's actually going to have. But certainly just monitor it. We can block every query, we can redirect. It's a variety of different potential policies or actions, I should say, based on the type of potential threat. And BlueCat's looking for things like entropy in the domain name. It's looking for number of unique characters, very long labels, and then also looking for patterns for things around, for instance, tunneling, where we look at a series of queries looking for rapidly changing, for instance, host names that also, or host labels that also are from domains we don't necessarily trust. You'll find many cases of things that look like tunneling that are simply your antivirus software working, for instance, because a lot of things out there that are installed on your devices use this very effective mechanism to communicate over DNS, and so therefore they are quote unquote tunneling. It's just not necessarily nefarious behavior. So that real-time analysis is critical. Of course, security teams don't want just a dramatic number of false positives, and we all know what happens. The system issues tons of false positives, and the security operations team is going to sort of stop listening to that signal. And so that's one of the reasons we sort of have these different echelons, but also it goes into how you plan and how you plan policies. It's very difficult to predict user queries. You have to remember with DNS that just because there's a query doesn't necessarily mean there was user intent to go to that website. For instance, if you're just on Google and you start typing something, Google does all this look ahead, assuming you haven't turned that off, to go try to get some information about the domains as you're typing characters. And so you'll find a whole series of domains that no user actually went to. They never actually clicked a link to go to that site, but certainly there was a DNS query or advertising on a web page. So users can be very noisy, and so we need to look for specific things that really look bad around threat lists, so that we can sort of dampen down those false positives. For infrastructure devices, for instance, like this Orion server, however, there's a much more predictable set of queries. You don't expect your infrastructure devices to start querying random DNS names out there, certainly DNS names on top-level domains that are known to be highly associated with spam and malware. They just don't do that. They're also quite predictable. They issue the same queries over and over and over again. And so that allows you to sort of narrow down. And so, if one of those user-driven devices goes to a perfectly normal domain, one of those infrastructure devices go to a perfectly normal domain like google.com, for instance, it's potentially a bad thing because it's potentially something installed there trying to figure out, create what they think looks like normal behavior and try to figure out if there's a route out via DNS, for instance. So they might start with doing some queries that aren't necessarily to bad domains, but just indicate that something is going a bit off on that device and something that should be looked at. Another slide there. So again, we do a lot of work to specifically mark those queries that should be looked at, and of course, go ahead and block those that are certain to be bad based on your policy. What we don't want to provide is, and we can, but what most of our customers don't want is just a massive fire hose of all this data, because it brings in a lot of noise that is interesting noise, especially if our customers are doing their own advanced data lake type analytics with combining DNS data with other signals out there. Then maybe they want all that noise, fine. But in cases where you're simply looking for enriched signals to try to understand if something should be followed up on, then all of that noise can create a lot of inefficiency in that process, and makes the signal less valuable. So that narrowing down or making the haystack smaller is something that we push on. And let me show you an example of that. Okay, so just a very quick example. So like I'm just going to look at a series of domains issued from my computer and my user-driven desktop here, just to show you the the massive list of domains you're going to get, and many of these things, again, things I don't necessarily had queried, but it's just based on what I'm Googling, what I'm using. Obviously, I'm not on a lot of Zoom calls, but you just, a huge fire hose of queries coming out of it. If I look at something that is infrastructure, like a Ubuntu server I have that I do a bunch of builds on, then what I end up with is something way more manageable. I mean, I just brought this thing up this morning, but you see other than CNN.com, which I queried on specifically just to make sure DNS was working, the rest of this is just system-driven queries based on what's running on the machine. It's a very small list. And based on that, we're able to craft policies that looks for anything other than those domains, and specifically looks to see if those things are, what threat indicators they might have. So again, you've dramatically reduced the size of the haystack because you're looking at infrastructure devices that have a predictable DNS pattern. You might not necessarily want to block everything that's not in this pattern because software patterns change slightly, but certainly block things that might look odd. So if I look, for instance, at, querying just with dig here, one of those domains that I look at quite often, and this is just sort of like a debugging view of dig I use, but I see in this case here, the important thing here is no policy was applied. This query went through and it went through fine. And it went through fine because it's a normal query. If I look at something that I've never queried before, like example.com here, what the system will come back is saying it's monitoring that query, and it's monitoring that query because it's unknown. We don't normally have seen that domain, but it didn't trigger any potential threat policies. So based on the policy I created, and if you stick around for the after show or whatever Jim calls it, then you'll sort of see how to create those policies. I said, yeah, fine, monitor this. And so I got an actual answer for this query. But if I'm in SecOps, I can trigger off that monitor and, sort of put it in the background and something I should go take a look at. Example.com is a fine domain. And so I'm not going to worry about that one. And I can whitelist that. If I look at something, I'm not going to query the actual domain from Solarwind, but I just put a test in here, but something that doesn't look particularly normal. Then when I see the system come back with is oops, what did I do? Oops, I forgot one more thing. Well, I annexed domain it. I don't know why my debug stuff isn't working here, but we automatically blocked this query. We automatically blocked this query because it had these sort of bizarre indicators on it that we didn't necessarily expect, and and that's what we're trying to do here: narrow down the playing field, like narrow down that haystack, make it smaller and smaller and smaller, and make it obvious when something is going wrong or bad, and block for that, and ensure all of this. I'm showing it to you from a DNS perspective, but all of this information is what we make available back in our data and then transfer to our customers' data so that they can see exactly what happened and transition this stuff. So again, key point is infrastructure devices should be monitored, obviously a whole lot closer than user devices. Obviously, user devices need to be monitored. My point is, though, that it's easier to detect for things that do have a normal pattern of work that something is different without even any machine learning. It just becomes obvious, and then the signals become way richer in the process. Send it back to you, Jim. So we will remediate that with policy, like I was just saying, and we can create policies based on a whole series of things, whether it's domains, domain lists from threat lists, whether it's specific threat indicators or threat types. Something looks like a DGA, it looks like DNS tunneling. We can do it differently based on source network or source IP. So you don't need to have a common policy. You can actually nail down a policy to a specific device if that's your intent, and have other things like allow different times policies are in place, for instance, but a whole series of possibilities there that we'll go through in the back end demo. But that not just providing our customers the data, but actually using this as a control point is critical. And again, with this back-end infrastructure, if you're monitoring it like this, then those queries, as Dave rightly said, were purposefully put onto domains that they had acquired, so they weren't brand new domains out there, and they acquired .com domains, not .biz domains or .accountants or some of the TLDs. that are known to have a ton of malware and spam and other things, but also like might look weird anyway. It's a .com and looked like it could be some antivirus software or something. But we would have triggered at least a monitor, and depending on your policy, potentially a block based on the type of query it was. So that's what we're trying to do here with Edge. Jim?
Great. Thank you, Andrew. It was a great overview of a couple of steps you can take through monitoring DNS. So a couple of things for the audience. I know we're right at the half-hour mark. So I hope you find the webinar interesting. We're going to get to Q&A in a second. Then, of course, if you want to stick around, we'll actually give you a demonstration of software that Andrew was referring to. There are some additional resources out there. Obviously, we are not the richest resource when it comes to Sunburst. There's a lot being published every day that David referred to. However, when it comes to using DNS, protecting your DNS, monitoring DNS queries, uncovering the gold in DNS queries, there are a number of assets we can offer right now. We do have a blog that's pretty extensive on Sunburst and Solorigate and what you can do about it. You'll find that on our website. We have an ebook called Exposing the Enemy Within that dives into the different types of DNS attacks and what you can do about it. And of course, we have an overview of Edge, the product, some screenshots that Andrew showed, and we're gonna give you more of that in a second. Those are all available on our website. There's URLs here. I'm sure you're not writing them down in your notebook quickly, so just go to the Googleator and search on Sunburst, Exposing, and BlueCat Edge, and you'll find those materials. So without a further ado, we'll just kind of give it a wrap. Sunburst basically is a very sophisticated attack. It had a very long timeline that David referred to. It used a number of sophisticated techniques, but really it's only the latest of a long string of attacks that exploit DNS. I think Cisco has the famous stat of 91% of malware uses DNS in some form. Sunburst is only the latest, and it's not the last, certainly. So if you're not monitoring DNS, we recommend that you get started. It's a gold mine for attacker, but also can be used by defense, and Andrew talked about some of that. DNS is a key area for better cooperation and collaboration between network ops and SecOps. SecOps doesn't want to be flooded with a ton of all that noise. They want to see the signals, and so it's a NetOps team that needs to find those signals and feed it to the security team. We'll talk about how we can do that in a second. And then log monitor, focus on the right queries and remediate. That's it. So why don't we get to some questions? I'm going to try to do that here. I'll look at my little polling. Again, the GoToWebinar software has an area they can add in questions, the Q&A feature. And yeah, so we got a question in here. I might as well shoot that over to you, Andrew. It's specific. So thank you for the good information. Specific to security product that you referred to, which we're going to show, what are some advantages over other similar products? Andrew, maybe you could take that one. I know there's a number of DNS security products on the market.
Yeah, well, I think one advantage for sure is the fact that we're definitely focused on security, but we're also focused on DNS. So we've built this resolver also to ensure the DNS service is more resilient. So the resolver itself has built-in load balancing and other capabilities to continue to answer questions, even if it's cut off from the back end. So it sort of actively ensures health of DNS. It also has a fairly unique capability to look across multiple authorities, and I won't get into the details of that, but that becomes very important for things like direct net access use cases and cloud use cases, where there may not be clean name server delegation as zones are delegated, or overlapping zones, for instance, and also the data and the analytics we're doing is super for understanding latency trends in the organization? Is there a heavy reliance on zones that have high latency even internally because of where zone replicas might be? So we've really positioned this thing to make DNS better, and then also add on the security side. So the other piece is, customers companies, I should say, spend a ridiculous amount of time trying to debug DNS query paths. DNS resolution paths are become complicated and timely to debug, and really it's our mission to make sure that those that are on the hook for ensuring that DNS always works have every tool in front of them to ensure just that. And so by not having a separate security product, but having that sort of built into the way you're doing DNS resolution in general, it also becomes easier to understand what's working, what's not working.
Yeah, I think that's a really good point, Andrew. And I would just add to that too, again, because the product that we're talking about is part of a DVI platform in general, because we are the provider of internal DNS. It helps solve some of that signal to noise just by its location on the network, right? The closer you can get to the originating device or IP address that's making the query, the better you're able to shrink the haste.
Absolutely, Jim, and that's the example I gave. I mean, if you're closer to that device and there's knowledge about those networks, and certainly from a full BlueCat platform perspective and an IPAM perspective, we have knowledge of those networks. Well, now you're not looking at the fire hose, and you can determine that what looks like a normal query for a user might be completely out of place for some infrastructure device.
One note that I would add, Jim, is that a number of companies that advertise themselves as providing DNS security depend very much on known blacklists. Their approach is not to dynamically analyze what's going through as queries, but to simply say, we've heard this is bad, so we're going to reject the query for you. And
right.
that provides you value to an extent, but it doesn't do everything that you can do with DNS.
Yeah, good first line of defense. And I think that actually ties into the next question that's in here, which is from where does DNS Edge get the threat data? How does that happen?
Yeah, so I mean, the threat data can be, we can certainly use our customers' threat data, and there's appropriate APIs in order for you to synchronize that data, and it remains your data. It doesn't go into the broad platform. And then we also provide data and make sure that data is updated and synchronized. So that's for the stuff that's known to be bad, that the indicators of compromise are already out there. Then it starts generating its own, and starts generating its own based on patterns of DNS queries. For instance, when it's finds something that, for instance, looks like tunneling or DGAs, and so that isn't a threat list. Rather, it's something that's generated during the time of query.
Great, good answer. Another question we have here is, will IPv6 complicate or simplify this?
IPv6 complicate or simplify this?
Or neither. That's a question.
I don't think either. I mean, for sure, in some cases of tunneling, the customers aren't using text records, or sorry, the malware is not using text records or CNAME chaining, or it's simply an A record. I remember reading a Cisco write-up of something 2 or 3 years ago, where literally, like, if the A record had this address, that was an instruction. If the A record had a different address. So for sure, IPv6, given that it's a much wider address, we have more options to embed information in what looks like a completely normal quad A query. But it doesn't. I don't think it's going to change whether this is. I think the rest of the playing field's mostly similar. Dave, do you think? Yeah.
Okay, great. Those are the 3 questions we received from the audience. I don't see any others coming in right now. So here's what we're going to do. It's about 11:41 local time. So why don't we I'm going to go ahead and just go to this product demonstration. Again, so that kind of concludes today's webinar. And for those of you that are going to depart, thank you very much for joining us. As I said, we'll make a recording of this available with the slides and additional materials that I referred to. So we will be in touch. If you'd like to stick around, we have a very quick demonstration of the software that Andrew and David referred to that I'm going to go ahead and play here for the audience. And if you have questions about that, I'll stick around. We can answer those as well.
Thank you.
Thank you.
Let me just figure that out. No, camera, go to video. And let me know if, for any reason, you don't see this, Andrew or David.
Hi, everyone. I'm going to walk you through a demonstration today of how DNS Edge helps set policies in place to help you reduce the time to detection, to narrow the scope of investigations, and then to help you remediate against threats sooner. In this case, we have a representative client site where we've set policies in advance based on the philosophy of the best offense is a great defense. We've set in place a policy already for a logistics warehouse within our network, where we understand that internal queries shouldn't be made in a very commonplace to the most sensitive areas of our network. So this might be in HR, this may be in finance, and we've set a monitoring policy in place, not so that these queries are blocked, which Edge does allow, but so that they're monitored, they're flagged, so that we can then look at them and then speed up, again, our ability to remediate any potential issues. In this case, we're noticing at the overview page that on the statistics graph that we have that charts the last 24 hours of activity in your network, that we have a blip here for the monitor policy. So what I can do is highlight that blip, and immediately I'm taking to our query logs. DNS Edge, through its service points, logs every single query because the service point acts as the first hop for all of your client devices. In this case, it is capturing all of this activity and displaying it to you in near real time. From here, you'll see that we've flagged that particular date and time stamp, as well as all of the queries that have been flagged by policy action. In this case, what we'd really like to focus on are just those policies or just those queries that were flagged from a monitor policy. So here we see a particular site. This is the logistics warehouse, that we have a machine that has become very active pinging our internal corporate domain. And this is traffic that's not usually supposed to happen, which is why we've set up that monitoring policy to flag it. We can then open up one of these queries and see the full breadth of the query, including its response and what has occurred. And here we also see the policy that flagged this particular query. Furthermore, as part of reducing your scope of investigation, we have the inspect client activity function. When you click on this function, it takes a snapshot in time of the traffic that this particular machine was performing 2 minutes after it had visited this site and performed this query. You can change that snapshot to be larger or smaller, or even before or after. In this case, we're going to increase the scope and take it to 20 minutes after it had made this particular query to our corporate internal domain.com. And as you can see, the traffic only gets more suspicious as the snapshot gets larger. And now I'm noticing that we have a query here that wasn't flagged by a monitoring policy, but is certainly suspect. Here, we're now able to look at a situation where is this a domain? Is this a situation that calls for an additional block policy as part of our remediation? Now that we've found this problematic domain occurring within the site, what we'd like to do and what Edge provides you with is the ability to create a block policy where we can take this avssws.com, apply it to a block policy as part of a domain list. And so traffic from that domain or going to that domain will no longer occur in your network until such time that you can confirm that this is indeed not a threat, or if it is in fact a threat that needs even further remediation. To do this, we're going to move to our domain list section, where we're going to create a domain list where we're going to include sws.com. We create this domain list, provided a description. It is a user-defined list, and here's where we're going to enter that domain. After saving the domain, we're then going to create a policy and apply this domain to that policy. So we come to our policy section, and we're going to add a new policy. We're going to call block new domain. We have two types of policy action. Now, we had previously talked about the monitoring policy, which is how we first found this problematic domain. And so you have two types of policy, an edge, block, or monitor. The monitor allows the query to continue its path to resolution, but it does flag it again to help reduce scope in case there's a problematic behavior noticed. But in this case, we know that there's a problem. And so we'd like the queries going to this domain to be blocked. Then we set this policy to active. We provide a description. And then we're going to state what sites do we want this policy to be applied against. In this case, we know the site that is part of the suspicious behavior. And then here we're going to add the domain list. Now, once I click Save and Apply, DNS Edge is going to take this policy and apply it to the site within a matter of minutes. So what you see is from the time of noticing the monitor policy being flagged at the overview page from our statistics panel, to traveling to our query logs, to noticing the suspicious behavior through inspect client activity, and then moving on to creating a policy that is then enacted at the site level, we are talking about a mere matter of minutes, going from noticing suspicious behavior to narrowing the scope to then a remediation policy being put in place.
Okay, great. So that was a great overview by Pablo. Thank you very much. Very smooth presenter, Pablo. That's a quick overview, about 6 minutes, 6.5 minutes of stop sharing here, of that is called BlueCat Edge. Again, that is our resolver as security and networking benefits that we've been talking about here. So if the audience has any questions about what we just showed, or there are still questions that you have from the webinar that demonstration triggered, we are happy to continue answering those. I'm going to check right now questions, see if any others came in. We have a couple more here. So question we have, is there any plans to have predefined categories available so that you can build a domain list that will block a category? So I think that's a grouping of categorization of domain lists. I don't know if Andrew's still on. I see you, David. Maybe you can take that one.
Sure. So we have had that request from customers, and we do have information in some of the threat feeds that we consume that breaks down into individual categories. So we will be exposing that at some point. We don't have a specific time that that's going to be available in the product just yet, but it's on the medium to longer term roadmap.
That's great. Okay, good suggestions. Clearly something that we're thinking about. And that is the only other question I see in the Q&A feature, which is good. We're at 11:50, a little beyond the time frame that I thought we were going to do. So for those of you that hung around for the backstage pass, right, the after party, so to speak, with Edge, thank you very much. If you have any other additional questions, you can reach out to us, reply to the email when we send you the link to this. You can come to our website and fill that out. We are here to answer any questions you have. And again, thank you very much for taking the time, and enjoy the rest of your day.
We should invite people to Network VIP as well. If you want to talk to other networking professionals, join our Slack environment that we host called NVIP. There's a link on our website, and I'm sure it'll be in the follow-up email as well.
That's an excellent point. Look at David doing the marketing for me. We have a spot for you on the team. Thank you very much. Appreciate it and have a great day.
Thanks, everyone.